right, in this chapter, we're going to start naming compounds and writing formulas for compounds. Really, it is the foundation of what you need to understand to move on in any chemistry class, and it's something that nobody else is probably going to teach. It's going to be just understood that you can understand the language of chemistry, so it's important that you be able to do this stuff. The first thing you have to understand when you're naming or writing formulas are the charges of the individual elements that you can have, because the charge of the element will determine what the formula of a compound will be. So, and the charges are determined by the number of valence electrons that elements have. And hopefully at this point, you know, if you look at column 1, you would know that there's one valence electron. And then the question you always have to ask in that case is if everything in column 1 is one valence electron, what would they do with that electron? Because they all combine with other elements to have 8 in their outer shell. One of two ways they could do that. They can lose or gain electrons. Well, if they have 1, in order to get 8 in their outer shell, they can lose 1 or gain 7. You know, what sounds easier to do? Because if they lose 1, the next level has 8 electrons in it and they would be stable. So everything in column 1 would lose 1. They're losing negative, so that means that they're lost a negative, and now that they're plus 1. So everything in column 1 would have a plus 1 charge. Column 2, they have 2 valence electrons. Everything in column, they're going to lose them. When they combine with another element, they'll be plus 2. Then it's a little bit inaccurate to say column 3 is plus 3. Really and truly, the metal part of that, we can say aluminum there is plus 3. And also, while I'm at it, zinc and cadmium together are always plus 2, because these transition metals here actually can have more than one charge for the most part, because of the fact that they have these d orbitals and they're close to the s orbitals, and so they can have more than one charge. But zinc and cadmium are always plus 2, and then silver is always plus 1 as well. And also, so as we move on, so we can say, we can't really say everything in group 3 is plus 3, but aluminum certainly is. And then column 4, they typically don't form ions, so we really don't need to say plus or minus 4. And then when you get to column 5, they have 5 valence electrons. You know, what sounds easier, losing 5 or gaining 3? They'll gain 3, and so they're gaining negative. So column 5, and that would be just down to the line here, just the nonmetals would be negative 3. The elements down here, these are the post-transition metals. They act like the rest of these, and a lot of these down here actually are positive ions. They could have more than one charge. So we'll talk about how to deal with those at a later time. Column 6, again, we got 6 valence electrons. They're going to gain 2 to have 8, so they're negative 2. Column 7, negative 1. And again, column 6 down to the line, we'll say that they're negative 2. And remember, again, down here in the notes part of this, I want to point out again that silver, cadmium, and zinc, they always have, you know, a consistent charge. Their charge does not change. The transition metals, however, can change. So we have to deal with them a little bit differently. So it says here, what's the charge of each ion typically formed by each element? All you got to do is find where it is on the periodic table to answer that question. So find sulfur right there. So sulfur is minus 2. Notice it said lead with 4 electrons lost. And lead is here. It's lead, move that up for you there. Lead is right there. It's a post-transition metal. So we can't say that it's always 4. It can be 4, but it's not always 4. But if they're telling it lost 4 electrons, it would be plus 4. And then the next one, strontium. There is strontium. It's in column 2, so obviously plus 2. Argon. Argon is right there. Do the noble gases have a charge? They don't. And bromine. Bromine's right here. So everything in column 7 is negative 1. Copper with 1 electron lost. Again, copper, the reason they're saying that is copper's right here. And copper can be plus 1 like silver, but it can also be plus 2. That's why, because it's a transition, metals can have more than one charge, so that's why they have to say there's 1 electron lost, and in that case it would be plus 1. And this, I know there's a lot of things difficult about this year, but in chemistry, I can't tell you the number of complaints I've received over the years, because in pre-AP, you are required to know all those polyatomic ions. It is the language of chemistry, and if you can't speak it, you can't talk, with another person about chemistry later on if they're talking about calcium carbonate and you don't know what carbonate is. So we require people to learn these every year. Well, obviously, since most of you are at home, we're not going to require that. You will always get the polyatomic ions as a source. You don't realize how big a deal that is and how much it makes your life easier. But again, you're going to have them. We're not going to require you to learn them this year. Hopefully, you will use them so much that you will start to learn what carbonate is and what nitrate is and so forth throughout the rest of the year. So again, don't have to, your polyatomic ion list will be there for you, obviously, in your notes when you're taking a test. So that'll be a big help when you're doing all this stuff. And anyways, that's it for this section of notes, because this is for, again, Tuesday and Wednesday where we have the PSAT, so it's a very light day. You have just a POGIL to work on as well. So that's it. Good luck.